Structured versus object-oriented programming. Every programmer knows that writing code is only a small part of the job. The more crucial task is designing the logic behind the code. In this realm, two primary approaches to software design exist: structured programming and object-oriented programming. Understanding their differences is key to choosing the right one for any given project. The roots of structured programming. Simplicity and control. Structured programming emerged in the 1960s to combat the chaos of old code, which was often referred to as spaghetti code. This method is built on a simple principle: a program should consist of small, orderly, and predictable functions. Advantages: high readability. Because it uses clear control structures like if, else, and for while, the logic is easy to follow and understand. High performance. This approach has low overhead, making it ideal for programs that require high speed and minimal memory consumption, such as embedded systems or hardware drivers. Simplicity. It's generally easier for beginners to learn as it avoids complex concepts like inheritance or polymorphism. Disadvantages. Complexity management. As a program grows, the number of functions increases, and the relationships between them can become difficult to manage. Limited reuse. Functions are often difficult to reuse in other projects because they may be tightly coupled to specific data. The rise of object-oriented programming. Modeling the real world. In the 1980s, as software became more complex, a need for a new approach emerged. Object-oriented programming (OOP) was developed to model the real world more accurately. In OOP, everything is an object that encapsulates data, like color, size, and the behaviors related to that data, like moving, changing color. The four pillars of OOP help solve the problems of structured programming. Encapsulation packages data and its related functions into a single unit called a class. This prevents data from being unintentionally modified and improves code security. Inheritance allows for code reuse. You can create a new class that inherits all the features of an existing class and only add or modify what you need. Polymorphism enables a single name, e.g., a method named print, to have different behaviors in different classes. This makes the code much more flexible. Abstraction hides the internal complexities of an object from the user. The programmer only needs to know how to use the object, not how it works internally. Advantages: high maintainability. Thanks to its modular and organized structure, finding and fixing errors in large projects is easier. High reusability. Through inheritance and objects, code can be easily reused across different projects. Scalability. OOP is the best choice for building large and complex software applications. Disadvantages. Complexity. The concepts of OOP can be challenging for beginners to grasp. Higher overhead. Managing objects can lead to more memory and processing time consumption. Conclusion. Your choice shapes your project's future. The choice between structured and object-oriented programming depends on the nature of your project. If your project is small, requires high speed, and needs low memory consumption, e.g., a simple script or a microcontroller program, structured programming is the better choice. If your project is large, complex, and requires high maintainability and future extensibility, e.g., enterprise software, a video game, or a mobile application, object-oriented programming is the more powerful and suitable solution. Ultimately, many successful programmers use a hybrid approach, combining the strengths of both paradigms. The most important thing is to understand the concepts and choose the right tool to solve the problem at hand.